back, guys. In this video we will start solving the most important problem in this part, and this problem is basically to write a script that can call this function called the triangle inertia to find the moment of inertia around the centroid, around the base, and around the vertex of a triangular shape given the base and the height. And the objective of this script is to print out this table. In this table we have three different values of B and H, and we need to find the corresponding values of the moment of inertia around its centroid, base, and vertex. Now, of course, guys, I should give you all the equations because my main objective is to test your programming skills and not your statics knowledge or any other field. So here I know that the moment of inertia is equal to I centroid plus the area times the distance squared, and this is the parallel axis theorem, where this distance is the distance between the centroid and any other axis that we need to find the moment of inertia about. So I know that IC is 1 over 36 BH cubed, then I about the vertex will be this IC plus the area of the triangle, which is BH over 2 times D squared, and D now is the distance between the centroid and the vertex. And then if I need to find IB, it will be IC plus A, the same values times now the distance between the base and the centroid. So this is how we can find the equations. Now, how to build this user-defined function? Of course, I should start by this line here. I have 3 outputs, 2 inputs, and then I should write down the equations. So let's find out how. Now, I did a slight change. Basically, I call this function TR because I have already the user-defined function called triag. And then I defined, of course, the 3 outputs, the 2 inputs. I started by IC, BH cubed over 36, because I know B, I know H, so I can directly find the moment of inertia around the centroid. Then I find the area of the triangle, which is BH over 2, because I should use it in the parallel axis theory. And then for the first moment of inertia around the base, the distance between the centroid and the base is H over 3. So I define this D, and then I used the parallel axis theorem to find IB, and then I did the change on this D, so now D is overwritten with another value, which is 2H over 3, and this is now the distance between the vertex and the centroid. Remember, we know that the centroid will divide the median between 1 over 3 H and 2 over 3 H if this is the centroid. So I know that H over 3 will be the distance between the centroid and the base of this triangle, while 2H over 3 will be the distance between the vertex and the centroid. So now this is I vertex, it is IC plus AD squared. So this is basically the function, very easy. I'm gonna ask you one question. What do you think will be the variables that will be shown in my workspace whenever I call this function? Basically, what matters by calling the function is IC, IB, and IV. These are the outputs that I need to see. So if you guys try this function, not on a script, you can try it first on the command window to make sure that there is no errors on this function. Let's say I'm gonna clear all my variables, and then I'm going to try this function by specifying the 3 outputs, because if I did not specify the 3 outputs, Matlab will only give me the first output, which is here IC. So let's say IC, IB, IV is equal to T underscore I. Remember, I should have the same file name as this function name, and then I should specify b and h. Let's say b is 1 and h is 2. So as you can see, guys, now the workspace is empty because I clear all my variables. Now if I click enter, then without a semicolon, then the command window will give me ICIBIV, and then here I will have them in my workspace. You can see, guys, that I don't have here any A or any D because in fact they are not outputs, and these variables will stay in the workspace of the function. So I will not have any variable that is not output, any variable from the function that is not an output in my workspace. Now what I can do also, I can define b and h. Let's say b is 1, h is 3, and then page up, find ICIBIV for this B and H, click enter. Now here, since I'm defining B and H, you will see B and H in your workspace, but again, you will never see D and A because they belong to the workspace of the function. Now this is the first part of the problem. The second part is basically to print out this table by calling this function 3 times in a script. So how to do this, guys? Basically what I'm gonna do now, okay, to clear all my variables and to clear my command window. And then, guys, I'm gonna show you what I need to see from the script. So if I run the script, basically I solved this problem. If I run the script, you can see that this is the table that I need to see. In fact, guys, if I ask you to print out a table, I will give you the table by running my solution, my script. So I'm going to give you this one, not the one that you can see here. Because in fact, you cannot do this vertical line. Alright, so you cannot do this vertical line in Matlab, and at the same time, you cannot print out 4 as an exponent. So basically, this is what you're gonna see if you run a script by using fprintf. So if I ask you guys to print out this table by calling the function that you've just developed, which is here ti, 3 times for 3 different combinations of b and h. And then, by using fprintf and the formatted output that we have explained in the previous video. Now guys, the first line of this table is only underscores, and you can also use dash. So it is only underscores, and you can do this by simply saying fprintf and a certain number of underscores between quotation, and don't forget \n, because if you don't put \n, otherwise all these printed out variables or values will be printed out just close to this underscore line. So guys, don't forget \n to go to the next line. So I have the first line here, which is a series of underscores, so you can simply do this by printing out this underscores line. Now the second line is to specify the title of this table, which is B in meter, H in meter, IC in meter 4, IB in meter 4, and IV in meter 4. So what I'm gonna do, I'm gonna print out this line here with a \n. And then after this line, I have a series of underscores, so I'm gonna put the same number of underscores used in the first row. Because if you don't do this, if you put more underscores here, you will see an additional underscore here, and this is not convenient. And then guys, for the first combination of B and H, I'm gonna call the function, so this is the first B and this is the first H. I'm gonna call the function ti to find IC, IB, IV for this BH that I have defined here. Now, how to print out the values of IC, IB, IV, the values of B and H in this row? So I'm here now. How to print out this? Basically, guys, you can count the spaces reserved for each variable. So let's start by this is 3.0. Now this is 3.0 means that I need to use 0.1 percentage 0.1f, alright, because I have one decimal number. Now what is basically the spaces reserved for this 3.0? I have 1, 2, 3, 4. So guys, if you use 4.1 for this 3.0, Matlab will keep a space here because in fact this number is only formed by 3 digits. The first digit is for 3, the second digit is for 0, and the third digit is for 0. The second digit is for this decimal point, and the third digit is for 0. Now, if you used 4.f, percentage 4.f at 4.1f, this means that you need to reserve 4 digits, including the decimal point and the decimal number. Alright, so that's why Matlab will move this 3.0 by one space. And you can now make sure that this 3.0 is under this B, because in fact, as you can see here, I also move this B by one space. So now this 3.0 is exactly under this B. Now what about 4.0? What do you think is the number of spaces reserved for 4.0? Basically, guys, for this 3.0, I have ended my value at this point here, at this 0. So I have 1, 2, 3, 4, 5. So for this 4.0, I'm reserving 5.1f. So that's why, guys, here I have a 5.1f. And so you can continue this. So guys, 1, 2, 3, 4, 5, 6, 7. Now this is 7.3f because I have 3 decimal numbers here and so on. Now, what you can do also to simplify your script is basically whenever you do this for the first combination of B and H, you can copy paste this and only change B and H. So now B and H are 2 and 3. And then you can copy paste this for the third combination for B and H, and then you will have B and H for B and H 1 and 2, and you will have the last line. And don't forget to end your table by a line of underscores. So this is what you can do if you need to print out a table. It needs some practice, some exercise. So what I'm asking guys to do as a take-home assignment that is also graded is to have your own function and your own script for any engineering problem. What I want you to do is to write a script that can call a function that you should define 3 times, and you should end up with the same table or with a certain table as this case. But I want you also to attach a video like this one where you should describe first the question like I did in this video. So you should first describe me the question, the equations needed, and then you should describe me how you did the function and how you did the script and how you print out the table in only 5 minutes. Thank you.